Hello, good day. Welcome to our first topic of our basic calculus class, chapter 1 entitled Limits and Continuity. We have the section 1, 1.1 limit of a function. We have two objectives. Number 1, illustrate the limit of a function by observing some values of the function and the values of the function and its graph, and then distinguish the difference between f of a and the limit of f of x as x approaches a. So the concept of limit allows us to study continuous change. So ang calculus, to be specific, the concept of limit, we're going to talk about the words continuous change. And this is the basic idea about calculus, which is commonly described as continuous change, that is calculus. So calculus and limits, they have the same concept about continuous change. Okay, this principle is just like asking, tama lang sa pagpangutana unsay mahitabo sa area sa inscribed polygon. So when we say about inscribed polygon, inside a circle, as this illustration, there is a polygon inside. So inscribed polygon with n refers to the number of sides. As the number of sides increases without bound, without limit, the basic question in the study of limits is this: what happens to the values of the function of f? So in relation to the inscribed polygon, sa dihang magkadagkan ang iyang number of sides without bound, what will happen? And the same to limits, the study of limits is that kung sa'y mahitabo sa value sa function f, the function f as x. So takes the values close to a specific value a. So for example, x as approaches to a, or just like our x approaches 1. So sa dihang nagkaduol siya sa 1, kung sa'y mahitabo sa atong values sa atong f. So that is the concept of limit, right? Okay. The question is equivalent to asking the following: unsay mahitabo sa limit sa f of x as x approaches a. So unsay mahitabo sa limit sa value nato sa f of x. So ang f of x na ni siya specific nga gihatag nga expression, and then underneath ana we have x approaches a. A can be any value, can be negative or positive side in the value of a. So what is the limit of our f of x sa dihang ang atong x magkaduol paingon sa given nga value of a. So that is the limit of the functions. Example, consider the function defined by our f of x is equal to the quantity of x minus 1 times the quantity of 5 minus 2x all over x x minus 1. According to the problem, you need to determine the limit of f of x as x approaches to a, finds our a is equal to 1. So here we have f of x as x approaches to 1. Or it can be written as this one. Uh, limit quantity of x minus 1 times 5 minus 2x all over x minus 1 as our x approaches 1. Okay, so we need to determine the limit. So what is the limit? What is the value as we approaches closer and closer to 1? So that is now our target. Notice that f is not defined at what? X equals 1. So, ang gibutang lang is our x approaches to 1, hindi x equals 1. Now, our concern is to observe the values that f takes as x becomes what? Closer and closer to 1. So, unsay value ni f sa dihang ang atong x nagka-duol sa value nga gihatag ni limit, which is 1. Diba? Mani atong target ang values ni f sa dihang magkaduol-duol ta closer and closer to 1. Dili ang value ni f diha sa 1. If this symbol equals is different from approaches. When we say approaches, nagka-duol kang 1 compared to x equals 1. So on the note, we may still get the limit of a function as x approaches a number if it exists. So kung naay limit nga nag-exist, so we can have this one approaches a number even though the value of the function at that number does not. So mag-discuss ta further aron makuha na to ang concept about limit. Continue. In the graph, okay, in the graph of f, observe that as x, yung x, takes values sufficiently close to 1, the values of f become closer and closer to 3. So take note our f of x in graphing that is equivalent to our y. Since our x refers to the x-axis, our f of x refers to the y-axis. So kung itong tanawon sa dang magkaduol ang value niya kang 1, ang mahitabo po diri ang side is magkaduol po siya nga ri sa 3. Ito. So this symbol is an open interval. That is, if we keep on choosing values of x that are close to 1, we can trace, ito yung mga values na closer kang 1. This in between 1 and 2, and in between 0 also and 1. So through this graph, we can say that the values of y are close to 3, right? So meaning, there is a limit existing to our given example, which is what? 3. So to discuss further, note that choosing values close to 1 means taking values. Sa hinamduman ang pagpili sa mga values nga closer kang 1, magikan na siya from the left side of 1, which is here, and here. Kadtong close lang kang 1. So if nag-meet sila diha ang apart and tanaw nimo sa graph nga nagtagto po sila, then that is the limit. So in this graph, makita nato nga nagtakdo sila in this area, which is 3 in our y side. So we can say that the limit of f of x as x approaches 1 is 3. Okay? So f of x, the limit of f of x as x approaches to 1 is 3 through this So in symbols, we have this one, limit of f of x. So may kulang ta dire, the word limit. Since we find the limit. Okay. As x approaches to 1 is 3, or we can give the value of our f of x, kaganina, which is limit of x minus 1 times the quantity of 5 minus 2x all over x minus 1 as x approaches to 1 equals 3. So there is a limit that existed. Also, we can get also the limit by not just magtanaw lang ta sa graph. If available ang graph, makita nato. If nagtakdo siya, there is a continuous, so means there is a limit. Pero if there is none, wala siya nag-continuous, so it is accepted if it is open or closed interval, as long as continuous siya. Minaw nga, before ta makahimo sa graph, in math, we need to do the tables. So by doing the tables alone, and without the graph, kaya dili man ta makagraph og way value ni table. So we can say easily if there is a limit existent. So to further verify that we obtain the actual limit, let us assign some values to x that are close to 1 and observe the values that f takes. So as you observe, we have the x side and we have the f of x, or the output, the value. If the value here substituted to the given expression, the result will be put here, the f of x, or the output. So as you observe, we have our x. Since our x kaganina is approaches to 1, so here, from 0.5 until 0.999, wala siya kaabot sa 1, pero closer to 1. Right? Kumbaga, this is 1 sa number line, this is number line. And then here, 0, and here is number 2. So, in this side, diri makita nato sa 0.5, paingon diri sa 0.99. Closer and closer to 1. Pero, hindi siya equal to 1. Closer lang. The other hand, we have 1.5. Here, it is in between 1 and 2. Right? And then, nagpaubos po siya paingon dito sa 1. So, 1.1, 1.01, until 1.0001. So, hindi siya 1. That is 1.001. Becomes closer and closer to 1. So, here, it is from the left. If I'm facing with my screen, according to the definition yan, from left. And then, the report is from the right. Okay? So, here is the given. So, yan. Kapag magtakdo sila, here, ang clue lang, pag ang value niya dire is na sila usa ka padungan, dire the end, meaning they have the existing limit. Kumbaga kung mag-graph ka, they are connected. Ana naman declare na to if there is a limit existed. Okay? So, let's try kung unsa ang value nga mabutang nato sa f of x. So let's start with 0.5. So example, based on the given, our x, okay, our x is equal to 0.5. So kanito lang gamiton. I will not going to copy this one, or okay, ako na lang. So x minus 1 times 5 minus 2x over x minus 1. So, i-substitute na to ang value ni x, which is 0.5. So, this is 0.5 minus 1. Sa PCAS pod, 5 minus 2 times 0.5 all over 0.5 minus 1. So what is the answer now? So for 0.5 minus 1, that is negative 0.5 times 5 minus 2 times 0.5. What will be the result? 2 times 0.5. The answer is 1. Then sa obos pod is 0.5. And furthermore, you may cancel this one. Right? Negative 0.5 divided by negative 0.5, that is 1. So 5 minus 1, that is 4. So in 0.5, our output is 4. Maklaro. So that is 4. Change natin ng color. Ganun. Ayan. In x, 0.9, our x is equal to 0.9. So using the given, x minus 1 times 5 minus 2x over x minus 1. Substitute lang. 0.9. Okay. Erase na to. Minus 1 times 5 minus 2 times 0.9 over 0.9 minus 1. Now, what is 0.9 minus 1? That is equivalent to negative 0.1. And then what is 5 minus 2 times 0.9? So 2 times 0.9, that is 1.8. So 5 minus 1.8 all over, so that is the same, 0.1. So still, you may cancel this out, or that is equal to 1. So we need to focus on 5 minus 1.8, which is equal to 3.2. So here our 0.9 is 3.2. And then x, 0.99. X is equal to 0.99. So x minus 1 times 5 minus 2x all over x minus 1. So 0.99 minus 1 times 5 minus 2 times 0.99 all over 0.99 minus 1. Now what is 0.99 minus 1? This is equivalent to negative 0.01. And then 5 minus 2 times 0.99. That is 1.98. Okay. So here, negative 0.01 said na. So still is equal to 1. So we need to focus to 5 minus 1.98, which is equivalent to what? 3.02. 3.02. So this is 3.02. Then x is equal to 0.999. So x minus 1 times 5 minus 2x all over x minus 1. So our x now is 0.999 minus 1. Tapos 5 minus 2 times 0.999 all over 0.999 minus 1. Now what is 0.999 minus 1? That is negative 0.001. And then here, what is 2 times 0.999? That is 1.998. So we have 5 minus 1.998. and the denominator is also negative 0.001. So here, minus 5, we got 3.002. So this is 3.00. And the last, we have x is equal to 0.9999. X minus 1, tapos 5 minus 2x times 5 minus 2x all over x minus 1. Substitute, 0.9999 minus 1 times 5 minus 2 times 0.9999 all over 0.9999 minus 1. So what is 0.9999 minus 1? That is negative 0.0001. So here 5 minus 2, okay? 2 times 0.99. Let's check. 2 times 0.9999. That is 1.9998. 1.9998 all over negative 0.0001. What is the final answer now? That is 3.0002. 3.000. See? So, here, our x, and sa na atong gi-substitute siya sa given, now our output, the f of x here, 4 then down to 3.00. So, inanaon lang. That is the basic principles how you're going to do the substitution, which is a very important skill in calculus. Okay? Next table, this is from the right, if facing ka dire. So, the same, substitute lang nato. So, first, the value here is x is equal to 1.5. So, our x minus 1 times 5 minus 2x all over x minus 1. Yan. Then, substitute lang nato. Okay? So, our x is 1.5 minus 1. Then, 5 minus 2 times 1.5 all over 1.5 minus 1. So 1.5 minus 1 is equal to 0.5. And multiply lang nato sa 5 minus 2 times 1.5. So 5 minus what? 5 minus 3. 0.5. So the answer now is 2. Okay, so 1.5, the output or f of x is 2. Next is x is equal to 1.1. So x minus 1 times 5 minus 2x all over x minus 1. Substitute lang po nato, 1.1 minus 1 times 5 minus 2 times 1.1 all over 1.1 minus 1. So what is 1.1 minus 1? That is 0.1. And 5 minus 1.1 is 2.2. All over, again, 0.1. So now what is the answer? If 5 minus 2.2, the answer is 2.8. So here we have 2. Next, x is equal to 1.01. So x minus 1 times 5 minus 2x all over x minus 1. Substitute lang nato, 1.01 minus 1 times 5 minus 2 times 1.01. Tama ba? All over 1.01 minus 1. So 1.01 minus 1, that is equivalent to 0.01. times 5 minus 1.01 times 2, which is equivalent to 2.02. 0.01 din yan. So, 5 minus 2.02, the answer is 2.98. So, 1.01, ang atong output is 2.98. So, that is the basic skill in substituting. Next, our x now is x is equal to 1.001. Then, x minus 1 times 5 minus 2x over x minus 1. Substitute lang. The value of x is 1.001 minus 1. And then 5 minus 2 times 1.001. All over 1.001 minus 1. So here, 1.001 minus 1, that is 0.001. Then 5 minus 2 times 1.001, that is 2.002. All over 0.001. So what is the final answer? 5 minus, no, 0.001 and 0.001, that is 1. 5 minus 2.00, excuse me. So that is 2.998. So here, 2.998. So renta sa last, which is x is equal to 1.0001. So x minus 1 times 5 minus 2x over x minus 1 is equal to, substitute lang, 1.0001 minus 1, then 5 minus 2 times 1.0001. Denominator, we have 1.0001 minus 1. So next, 1.0001 minus 1, that is 0.0001. 5 minus 2 times 1.001 is 2.0002 over 0.0001. So what is now the final answer? 5 minus 2.0002, that is 2.9998. 2.9998. Okay, so again, just substitute lang. Okay. So here, so to further verify that we obtain the actual limit, let us assign some values to x that are close to 1. So this is only an example. Actually, ang tip lang ani is dapat closer siya sa given nga approach or the value of a. So kay 1 man, so ang close niya is 0.99 naman for the left side, and the right side we have 1.001. So as you observe, kaganina, 0.5 is 4, 3 point, and so on. So by observing alone here, they have what we call a number. Okay, 2.998 tapos 3.002. By looking along the table, there is an existing number nga mag-meet sila. Which is, kung imo ni siyang ipadayon, this will equal to what? 3. Kung kanipod, padayon pagpapaubos, that is equal to 3. So therefore, we can see and say that as x approaches to 1 and this limit, x minus 1 times 5 minus 2x all over x minus 1, that is, the limit is 3. Right? So we can observe in this table that as x takes values that are close to a, close to but less than 1, ito, the values are close to 3. And the other hand also, as takes values that are close to but greater than 1, we have this this area, the values also are close to 3. Therefore, our limit now is 3. Okay? So, ang tanaw lang nato is ang values from the left and from the right of a certain value. If kari closer naman ni siya sa 3, tapos kari pud kay pasaka closer sa 3, so there is a limit which is 3. I hope that is clear. Now, let's have the definition. Okay? Definition. Let f be a function defined on some open interval. So, we have the term, timan na nato, open interval containing the number a except possibly at a itself. May exemption, which is the a. Then the limit of f as x approaches to a is Rl, which is written in this form. Limit of f of x as x approaches a is L. So this is the symbol for the definition. If the values of f gets closer to one and only one number, which is our L, tama sa to example ganina, sa dehang ang value ni f either from the left or from the right, na closer and closer to one number lang, which is 3. As x takes values that are closer and closer to a. And that is our limit. Okay? Sa x table, that those are numbers that are to a. And the other side also, those are numbers closer to our f of x. Okay. So that is the definition. At hindi man na ng special na remark. Ito lang tagsa-tagsaan. Recall that an open interval, so open interval, by symbol alone we can identify this is an open. Pag ganyan ang gamit, that is open interval. Pag this one, this is close. So open interval C and D is the set of real numbers which what? Between C and D. Example, x such that C or x now is in between C and D. So that is greater than C but less than D. In the definition of limit, it is required to have an open interval containing RA. So this one, x approaches to A. If it is x approaches to 1, so it contains what? Open interval containing R1. Where the function is defined at every real number in that interval except possibly what? RA. It is important to remember that if no such interval exists, kung wala interval nga nag-exist, then the limit will not also exist. Okay? Inanara siya ka-simple na yung definition. Pag may nag-exist, then it's okay. Pag wala, then wala. Yes, the limit may or may not exist. Kaya ang limit, pwede daa, pwede pod og wala. Pero kung mag-exist ganing natin man, it is a unique. Now note that in a more formal definition of limit, the notion of what? Ano to timan-an? Closeness. Take note, closeness here in limit can be quantified. It can be turned into numbers. And syempre, pag may numbers, it can be analyzed. That's why calculus can be applied, very useful to real life. Because we can quantify and analyze such things. Also note that the limit of function as x approaches a is not necessarily equal to the value of the function at a. Hindi siya necessary nga equal. It's like kaganina, 2.998 tapos 3.002. But we can see that it's continuous. They can meet at the number 2. So there is an existing limit. To further discuss about this one, we need to consider these illustrations to graph. Sorry. Okay. So consider the function f. As observed from A, B, C, and D, we have only unique f of x, f of x, f of x, f of x. But our A, iba sila ng A. A is, our A for letter A is -1, for B we have 0, and C is 2, and then D is 4. This is our graph. Okay? So, ito na i-discuss ron. We need to evaluate the following limits. Nag-exist ba or wala? So, by just looking sa what? Sa graph. Atong tanawon kung nag-exist ba ilang limit. Okay. Let's have letter A. Excuse me. We have limit of f of x as x approaches to -1. Here, this is -1. Diba? What is the limit of our f of x as x approaches to -1? The value of the function at -1 is 1. Diba? So, the value of the function at -1 is 1. But we are not concerned with that. What we want is the value of f paingon sa as x approaches to -1. So, diyang si x, yeah, this is illustration, padung kang -1. Mo to concern. Dili kay the value of the function at -1 is 1. Notice that if that f still takes the values close to 1, diba? As x approaches -1. So, tanawin mo ang graph. So, dahil nagpadung siya pa ubos, padung sa diri. Yeah. Padung paingon. Mainly high. There's a point here. That is a closed interval 1, right? In which, in this side, we have 1. Values close to 1 as x approaches to -1. So, by looking along the graph, we can see and say that the limit when x or tends x approaches to -1 is the value here 1. So there is a continuous. So sa graph pa lamang makita nato nga there is a limit. Okay? So point of intersection lang for -1 and 1 is 1. So the limit of f of x as x approaches to 1 is, the answer now is 1. So by looking along the graph, masulti nato nga there's a limit, which is here. Okay? How about number 2? Number 2, limit of f of x as x approaches to 0. Here. Kaya naman ang 0 diri sa x. So, unsay na-observe mo sa graph? Compare nimo sa ganina, here, continuous. Here, lahi. We have this one. I think also this one. Notice that f is not defined at values close to 0. Wala. Meron siyang values here, pero pag amo diri wala. There's a gap. There's no open interval containing 0 in which f is defined. That's why in graph alone, we can say that the limit does not exist. Okay? Number 3. Okay. Limit of f of x as x approaches to 2. Here. So, kung imong tan-awon diya, we have this one. As x approaches to, observe that f takes values that are close to 3. Diba? So, in this area, was diri pod. Yeah, sila nagtagbo. We're not concerned with the value of the function at 2. Kita lang na to as f tends. Diba? Kadang si x approaches to 2, makita na to nga there's a connection here. This is at the point of 2. This is an open interval. So, what is the limit now? For f of x as x approaches to 2 is 3. And the last, limit of f of x as x approaches to 4. Here, kung tanan na to ang graph alone, we have this closed one, we have this open one. So observe that as x takes value close to 4, true values less than 4 in this area are here, What is the value of y? That is closer to 6. If it is greater than 4, here in this area, it takes what value? 4.5. So that is not continuous. According to our definition, dapat ano lang, dapat nata unique. Dapat kung 6, 6 sad na dire dapat nga sad. Pero here we have 6 and we have also the 4.5. Therefore, does not exist. Okay, dapat magkapareha sila compared here, also here. So the rest does not exist. So by looking along the graph, makita na nato kung nabay limit or wala. Kahit hindi na mag-solve for the tables. But basically, we cannot, if the given there's a graph, we can see directly. Pero pag expression lang, we need to solve first by using table. So that we can know the numbers. If meron ba sila the same nga padungan. Diba? So closer to a such number as our x approaches the certain value. Okay? Another example. Limit, let f of x, so may duha ta ka value kang f of x. X squared minus 1 as x is not equal to 0. And then f of x is equal to 1 if x is equals 0. So now our given is that determine limit of f of x are as our x approaches to what? 0. So sa duha sa atong gamiton, kaya hindi man equal sa 0, we are going to use this to be substituted. Now, the value of x rather. Okay, wala may graph ipakita, we need to use the table. Okay? So here, we have the table. Take note nga ang atong x approaches to 0. Meaning you can have the less number less than 0 and greater than 0. So in this side, we have less than 0. We have negative 0.5, negative 0.1, negative 0.01, negative 0.01, negative 0.001. On this side, we have greater than 0, from 0.5 until 0.001. Dapat yung value here sa f of x tapos dire, at sila usa ka number na unique nga padungan. Okay? So, let's try to solve. We have two equation rather. And we need to use x squared minus 1. Kasi pag x lang, equals 1, ito, we cannot substitute the value of x. Need that. Right? So we need to use this one. And take note, we have this condition. If x is equal to 0. Pero, in a limit, we're not using to, we're going to use equals. We need to have the approaches. Okay? So that is not equal to 0. Kami na ito gamitin. So, okay. So, here, our x is equal to negative 0.5. So, x squared minus 1 is equal to negative 0.5. Square of negative 0.5 minus 1. And the answer is what? 0.25 minus 1. I think negative 0.75. Okay? Negative 0.75. Next, x equals negative 0.1. So x squared minus 1 is equal to negative 0.1 squared minus. So 0.1 times 0.1, that is 0.01 minus 1, which is equal to negative 0.99. Okay, negative 0.99. And then x equals negative 0.01. So x squared minus 1 equals negative 0.01 squared minus 1. So what is 0.01 times 0.01? That is 0.0001 minus 1 is equal to negative 0.9999. Negative 0.9999. Next, x equals negative 0.001. So x squared minus 1 equals negative 0.001. The square of that minus 1. So 0.001 times 0.001 negative minus 1, that is negative 0.999999. So negative 0.999999. So there is a pattern actually. So here x is equal to negative 0.0001, x squared minus 1, substitute lang nato, negative 0.0001. Square of that minus 1. So the answer is negative 0.999999999. Right. That is less than 0. Now for greater than 0, x equals 0.5. So x squared minus 1 equals the square of 0.5 minus 1. So 0.5 times 0.5, that is 0.25 minus 1. So what? That is negative 0.7. Next, x equals 0.1. X squared minus 1 equals the square of 0.1 minus 1. 0.1 times 0.1, 0.01 minus 1, that is equal to negative 0.99. Okay? Next, x squared equals 0.01. X squared minus 1 equals the square of 0.01 minus 1. 0.01 times 0.01, that is 0.0001 minus 1. So negative 0.9999. Negative 0.999. So next, x is equal to 0.001. Substitute lang. So the answer that is negative 0.9999. So as you observe, the same pattern lang siya from the left side. Last, x squared minus 1 is equal to 0.0001 minus 1. Substitute lang nato. And the answer here is negative 0.99999999. Okay? So ang tanong, is there a limit? Let's check. So here's now the given value. The following table shows the values of f for some values of x that are close to 0. So kanina nga part, it is less than 0. This is greater than 0. Right? So you observe, they have equal f of x for output and negative 0.99, then negative 0.99. So kung atong tan-awon, andun na sila value. As they are close to 0, their f of x also takes the value close to what? negative 1. Therefore, the limit now is the limit of f of x as x approaches 0 is equal to negative 1. There is a limit. It's negative 1. Compared to the first example, which is 2.999 something and 3.02. So, kung imo padayon nun, magkapareha sila, which is 3. Here, like put, they have the same value. And that's why, mas dali sa matanawa na to. There is a limit. So, if you're going to graph this one, makita na to nga there is an existing limit, which is what? Negative 1. Okay, another. Evaluate limit of square root of x plus 1 as x approaches 0. Okay? So, let our f of x is equal to square root of x plus 1. So, by seeing the graph, there is what? Continuous. Ba? Padayon nga forma. So, probably there is a limit. So, take note, our x is what? Approaches to 0 here. So, what's the limit? We have this one area, which is 1. As we observe, as x approaches 0, our f of x also becomes what? Closer and closer to, this is our f of x. So, dahang padung ta sa 0, ang f of x po naapo diri sa 1. So, our limit for square root of x plus 1 as x approaches 0 is what? 1. Okay? And that's it for our lesson about limit of a function.